So we have now started about the redox equation, the introduction of that, and we have understood how to assign the oxidation state for each atom in a substance. So now we will be studying about how to apply those numbers into the more complex redox reaction. So far we have only discussed about the rather simple redox reaction. Now we will be taking a deeper look for the more complex one, which is usually performed in acidified condition. So in this case, not only that we have to take into account about the um, the atoms and the electrons movement, but also we need to pay more attention for the water molecules and the hydrogen ions, because we will also need to balance the quantity of oxygen and hydrogens. The note that I have to tell you here is be organized as it gets more complex. Okay, so what are the steps? Here I have listed the 5 steps of balancing the half equation. We will deal with the half equation first in acidified condition. The first thing is we need to balance out the atoms other than hydrogen and oxygen. So the atoms that is not hydrogen and oxygen here is the Cr, the chromium. So what I would do here is, as I have 2 chromium on the left, I will add 2 on the right. Okay, we are done for the first step. And then balance oxygen by adding water. As on the left we have 7 oxygen, means that on the right we will add it with 7 H2O. Now we have done with the first and second step. Now let's go to the third step, that is balance hydrogen by adding H+. As on the right we have too much hydrogen, which is 14 hydrogen. On the left we need to add 14 H+ on the left. We are done with the third step. Now let's go to the fourth step, that is determine the total charge on each side of the equation. On the left here we have 14 positive and 2 negative, so the total charge is positive 12. And on the right we have 2 of Cr3 plus, therefore plus 6, and H2O is neutral, so plus 6. We have determined, we're done with the fourth step, and we need to go for the last step, that is balance the charges on each side of the equation by adding electrons to the side with more positive charge. So we want to make the left hand side and the right hand side to have the equal charge. Therefore, we need to add 6 electrons on the left. 6 negative 6 plus positive 12 will be equal to the 2 positive 6. So now we have the balanced reaction as shown in the reaction. Okay, now after we have balanced the half equation, we can determine if Cr2O7 2 minus whether it undergoes a reduction process or oxidation process. Here, because it gains electron, we can say that it is a reduction. Based on the electron movement, we can tell that it's reduction. Then we can also determine the reduction or oxidation based on its oxidation state. Cr3 plus, the oxidation state is plus 3. For Cr2O7, we can calculate it 2Cr plus 7 times minus 2 equals to minus 2. 2Cr equals to positive 12. Cr is plus 6. Plus 6. The oxidation state of chromium changes from plus 6 to plus 3 because the oxidation state is reduced, therefore it is also a reduction. So whether we are determining the process based on the electron movement or based on the oxidation state, we will get the same result, that this half equation is indeed a reduction process. Now everything is balanced and the half equation is done. But we know that in a redox reaction, we are not only dealing with half equation, but instead we are dealing with a combined reaction. So I give you an example here, which is NO3 minus plus Cu turns into NO plus Cu2 plus. We can see that the charge is not balanced, the quantity of the oxygen is also not balanced. So what do we need to do here? Well, actually the process is similar to what we have encountered before in the half equations, but there are some additional steps that we need to do here. First, we can determine the oxidation state. Cu is 0. You can start at whichever that you feel comfortable. Cu2 plus is plus 2. O will always be negative 2. Therefore, the nitrogen in NO will be positive 2, and the nitrogen in NO3 minus will be positive 5. Okay. Now we have assigned all the oxidation states of each atoms, and we can observe that this experience a change, and also Cu also experience some change. This is oxidation, and this is the top one is the reduction. So we have assigned the oxidation state. Now we want to write the half equation. For the reduction process, it is from NO3 minus to NO. And for the oxidation, it is Cu into Cu2 plus. So again, as the previous step, now we are dealing with two half equations. So we need to do what's on the list again, which is similar. Balance the atom other than hydrogen and oxygen. In this case, we don't need, because in both reduction and oxidation process, the quantity of all the atoms other than hydrogen and oxygen are balanced. So we're done with the half equation and balancing the atoms other than hydrogen and oxygen. Now balance oxygen by adding water. we only need to add water at the top. We need to add 2 water and then balance hydrogen by adding H plus. We have 4 hydrogen on the right for the reduction. So 4H plus. Now we want to balance the charge by adding electrons. At the top, the left hand side is plus 3 and the right hand side is 0. So we need to add 3 electrons. Therefore, the charge on the left and on the right is the same. And for the oxidation process, we need to add 2 electrons at the bottom. We're done until the 5th step. Now equalize. Then this is the step that was not previously explained. Equalize the number of electrons in both half equations by multiplication. What it means is that our target is eliminating the electrons from the reduction process and the oxidation process. But now the quantity of the electrons on the 2 reactions are not the same, therefore we cannot eliminate it. What we need to do is multiply the entire reaction at the top by 2 and multiply the entire reaction at the bottom by 3. What we will have is 2NO3 plus 8H plus 6 electron give you 2NO plus 4H2. And then for the reaction at the bottom, 3Cu plus 3Cu2 plus 6 electron. Now we're done with the 2 half equations. We can eliminate everything that is the same. Not only electrons, if we have water on the left hand side and on the right hand side, we can also eliminate that. If we have hydrogen on the left hand side and the right hand side, we can eliminate that. If for example, for a hypothetical reaction, if A plus 6H plus becomes B and C becomes D plus 4H plus, we can also eliminate 4 of the entire 4 hydrogen, and now what remains is just 2 hydrogen on the left, but that's hypothetical. Now as we are done, I will delete all the labels first. So if we want to balance out the equation, we will have 2NO3 plus 3Cu gives us 2NO plus 3Cu plus. Then add the water on the right, add the hydrogen on the left. So now we are done with all the process. Okay, now let's do another reaction. Please pause the video if you need time to solve the problem. So now let's solve the problem. Assign the oxidation state. Sulfur is -2, this one is +3, oxygen is -2, this oxygen is also -2, the chromium is +6, the sulfur is also +6. Now we know that the Cr changes from +6 to +3, and the sulfur changes from -2 to +6. So we do know that in the reduction process we have CrO4 2-, and on the product we have Cr3+, and for oxidation we have S2-, and the product is SO4 2-. If needed, we need to balance out the quantity of the atoms other than the oxygen and hydrogen, which is not needed here. Then balance out the quantity of the oxygen. Now balance out the quantity of the hydrogen ion. Now we need to balance out the charge on the left and on the right for both process. So this one is +6, this one is +3, therefore we need 3 electrons here. This one is -2, this one is +6. So to make it equal, we do need 8 electron. So the top one, to make it equal, the top one needs to be multiplied with 8, and the bottom one needs to be multiplied with 3. Therefore, what we have now is 8 CrO plus 64H plus 24 electrons becomes Cr3 plus 8 Cr3 plus plus 32 H2O. For the reaction at the bottom, (3As2-), 12 H2O, 3SO4 2-, 24 H plus, and 24 electrons. Cross out the electrons, cross out the 24 H plus. Now we only have 40 H plus, 12 H2O, we only have 20 H2O. So the overall reaction is 8 CrO4 2- plus 3S2- plus 40 H plus gives us 8 Cr3 plus 3SO4 2- plus 20 H2O. And that's how you balance a redox reaction. Now let's solve the problem let's solve this problem. Pause the video if you need time to solve the problem on your own. Okay, so it gets a little bit different where we only have one substance on the left, but we can still do the balancing using the same method. Assign the oxidation number and the oxidation state -2, and this Cl is +5. So the Cl changes from 0 to -1, which is a reduction, and it changes from 0 to +5, which is an oxidation. For the reduction process, it is from Cl2 forming a Cl minus, and the oxidation is from Cl2 to ClO3 minus. We need to balance out. The first thing is the atom other than hydrogen and oxygen. Add 2 on each side. Balance out the oxygen. We have 6 oxygen. Then we need to add 12H plus here. The total charge on the left for reduction is 0. Total charge on the right is -2. Therefore, we need to add 2 electrons on the left. The total charge on the left is 0, and the total charge on the right is +10. Therefore, we also need to add 10 electrons on the right. Equalize the number of electrons. Multiply everything by 5. And we can eliminate the electrons. Therefore, the overall reaction is 6Cl2, because we have 5Cl2 and 1Cl2, plus 6H2O gives us 5Cl minus plus 2ClO3 minus plus 12H plus. Sorry, there's something that I need to revise here. We have 10 and we have 10. So we can stop here, but if you can notice, there's the number can actually be simplified further into 3Cl2, 3H2O becomes 5Cl minus plus ClO3 minus plus 6H plus. And that's how you balance the redox equation using half equations and acidic condition. So if we notice, there's a difference between this reaction comparing to the previous two reactions. For this one, the reducing agent is simply Cu, because it undergoes in the oxidation process, and the oxidizing agent is the NO3 minus. For this one, the CrO4 2 minus is the oxidizing agent, and the S2 minus is the reducing agent. But for this reaction, Cl2 is both reducing and oxidizing agent. Okay guys, that's all for the meeting today. I hope you learned something, and I will see you around in the next meeting. Cheers guys, bye.